All right, here we are given two triangles, PQR and ABC, and the conditions are given as such that AB, this length, is proportional to PQ, and AC is this length is proportional to PR. Also, the median that divides QM and MR equally. Similarly, BD and DC equally. Those two medians, PM and AD, are also proportional. So I have written that down in this manner. Now the question is that we need to prove that both of them are similar. The issue with similar triangles is that when you know two triangles are similar, so all the sides must also be proportional to each other. For example, if we assume, if assumed that triangle ABC is proportional to triangle PQR, then that should have been AB over PQ, that's equals to AC over PR, and the final one, that is BC over QR. Now if we have this ratio complete, then we can claim that the triangles are similar, right? Or if the triangles are similar, then we can claim that this ratio is true. Now for us, the condition is that AB, PQ, AB, PQ, AC, PR, AC, PR, they are given, but the final one is an odd one out, right? We have AD divided by PM, but we do not have BC over QR. Okay, so there are either two ways to do it, that we either prove that BC over QR is proportional to AD over PM. That's quite difficult thing to do. So instead what we would do is that we would try and prove, because for both the triangles we know that this holds true. Now if we somehow can prove that this angle P here, this angle P here is equal to this angle A there. Okay, if we could prove, if we can prove angle P is equal to angle A, then we can claim, together with this ratio and with the equality of the angle, we can claim that ABC is equal to is similar to PQR, and this is what exactly we are going to do. Okay, so I would be, because I have a very small workspace, so I would be removing things, but I expect you that you would keep notes of things yourself. All right, so to do this, what we do first is that we try and construct, we lengthen this PM of a similar distance MN, that is construct extend PM to PM to point N, so that PM equals MN, and create another triangle, that is triangle PQN. Similarly, extend AD to E and create triangle ABE, and AD equals DE. Alright, so far so good. Now what we'll do is that we will work on these two triangles. Let me mark them with the blue color once again, and this would look like, we would work on PQN and ABA. All right. So I hope it is visible here. Okay. So if we just focus on two of the smaller triangles, that is triangle PMR and triangle QMN. Okay, PMR and QMN. That means PMR is this one and QMN is the other one. Okay. These small green triangles. These small green triangles. All right. So we can see that QM equals MR because line segment bisected by the median. Right. Another thing we can see that PM equals MN because that was how we constructed those two triangles by construction, right? And then we can say that angle QMN is equal to angle RMP, and this is because vertically opposite triangles. Sorry, vertically opposite angles. So you can say that triangle PMR is congruent to triangle QMN, right? That would be our side criteria. So these two triangles, they are equal to each other, and from this we can find out or we can claim that because these two triangles are congruent, so we can say that PR is going to be equal to QN. So those two sides are equal, and this is a very, very important thing to consider, right? Now if I remove this part, right, let me remove this thing here. So similarly, for triangles ADC and triangle BDE, we can say in a similar manner, right? We can also create two small green triangles here. One is this one, and the other one is up here. Now, if you see both the situations of these two green triangles and those two green triangles are exactly the same. So therefore, we can just skip the whole process, and I can claim that triangle because all the process would be similar to these two triangles and those two triangles. So we can just claim that ADC is congruent to triangle BDE, and so we can say that the side AC is equal to the side B. Okay. If I may call this one as number 1 and this one as number 2. Okay, so all right, let me just say one more thing here as I'm writing. You see that because these two triangles are congruent, so I can claim that AC is congruent to BE. But I can also claim that the angle BED is equal to angle DAC. Okay, if you look at the shape of those two triangles, right? If you look at the shape of those two triangles, you can fit them on each other, because this AD would go and would flip and would go and sit exactly like over that. You see, because BD is equal to DC, so if I move it around, I will explain what I mean. If you see, BED looks like this. So this BE and D. Now, if I look ACD, you can see that ACD can fit exactly like so. Here, so this inside here, this is A, and this is D itself, and this angle here is C. Or am I wrong? Yes, I am wrong. This should be C here, this is D, and this one should be A. So you see that angle BED is equal to angle DAC, because this angle is exactly same to that angle, right? So in that manner we can say that these two angles are equal. It might look a bit confusing right now, but hold on, I will explain what I mean. Okay, since if I say, let me just call this one as 2 and 4, okay, IV, that's 4. Right, now if this is number 1, this is PR is equal to QN when we were dealing with these two triangles, so we can also claim that this angle is equal to that other angle, right? So we can write, so I can write here as angle QNM is equal to angle MPR, and let me call this as number 3. Okay, now when the things are sorted, let's go ahead and write this condition again up here, if I may. So I'll write AB divided by PQ, and that's equal to AC divided by PR, and that's equal to AD divided by PM. So we can continue writing here. I can write AB divided by PQ, and in place of AC and PR, I can replace AC as BE and PR as QN, right? So let me just replace AC, I will write here as BE, and PR I will replace as QN, and then I can write this, since this is AD divided by PM, I can also write it 2 times of AD, and I can write here as 2 times of, sorry, this is P and this is M, right? Now here I have AB divided by PQ, and that's equals to BE divided by QN, and 2 times of AD. If you see AD, this one AD, 2 times of AD means AE altogether, AE, and in the same way 2 times of PM would mean PN, PN. Alright, now we see that AB, BE and AE, PQ, QN and PN are the ratios of the 2 blue triangles. You see these 2 blue triangles here, this one, this is the first one, and that's the next one, okay, that's the next one, right? So when we have this ratio, so we can just as well claim that that triangle PQN is similar to triangle ABE. I hope it is visible. Yes, it is. Okay, so PQN is similar to ABE. Now when they are similar, then we can as well claim that that angle QPN is equal to angle BAE, isn't it? Now in similar triangles, incongruent triangles, all the sides of both the triangles are same while all the angles are also same. But in case of similar triangles, it's just the angles that are the same, not it's just the angles that are the same but not the sides. Sides are of equal ratios. So for similar triangles I can claim that this is true, right? Now another thing is that we had already proven that about these two things, number 3 and number 4. Okay, Q and M, this angle is equal to that angle. Right, then we can also say that if these two are equal, we can also say that angle QNP is equal to angle BEA. Right, those are two different angles and they are all equal to each other. Now QNP is here. QNP is equal to MPR. Angle MPR is equal to, if this is BEA, you can see here BEA is this one, or rather BED. BED is also same to as BEA. So you can say that this is angle BEA is equal to angle DAC, and here we have the same thing. So angle APR BEA, I can write it as angle DAC. Right. So far so good. All right, then I can maybe remove this part. If you see what we are working at, let me call this as number 1. This is number 2. This one is number 3, and this is number 4. I hope all this is visible. Right. Okay. So if I number them out like that, so you can safely say that angle number 1 is equal to angle number 3, and angle number 2 is equal to angle number 4. Yeah, okay. Then we can add them together, right? We can add them together, that angle 1 plus angle 2 is equal to angle 3 plus angle 4. And this gives us 1 plus 2 is this angle, this big angle, angle BAC, and that is angle QPR. Now if you would go back to the beginning of the video, you would realize that our goal was to find out this index angle to be equal to each other. This angle should be equal to each other, because we already have the ratio of the two sides. If we have the ratio of all the three sides, then there is no problem for us because they are similar to each other. But now we have the ratio of the two sides. Together with that, we have these two angles that are equal to each other. So you can say that now angle BAC is equal to angle QPR, and AB divided by PQ, that's equal to AC divided by PR. So we can say triangle PQR is similar to triangle ABC.